Today we're going to talk about data transmitting in a network, and we have two different kinds of network. We're going to talk about that is the packet network and circuit network. Today we're going to talk about data transmitting in a network. There's two different kinds. There's the packet network and circuit network. Packet network is the idea of sending data through packets, which means you can divide these packets in small pieces and then collect them at the end. Circuit network is a direct connection between receiver and sender. So the data transmission happens through without any interruption, you could say, at data, because it's a straight line that's come through. I will explain it better with the next slides. The first is the packet network, and depending on the OSI model you are working with, there's different layers, and we have this network layer and data link layer. On the network layer, we call this datagram switching because the idea of packet transmitting is now called a datagram. And you talk about this connectionless service. Connectionless, when something is connectionless in a network, it means that usually you don't have reliability. And that means you have no reservation, which means that the data can come in any order if it wants. So it's also out of order. So I can send packet 1, 2, 3, 4, but it can end up getting in the order 3, 1, 4, 2 example. And you talk about this principle with high overload headers. Headers is this, you can call the destination for each packet. So when we have this packet 1, 2, 3, 4 that wants to be sent, each of these packets have a header that tells them where to end in the end. So the end destination is on there. Usually when we talk about headers, it's the destination port and the source port, depending on it's just TCP or UDP, which you can search on Google, but it's basically the idea of reliability and not reliability. And of course, when you have something out of order and something that just came go through this network independently, each of these packets, you will get an increased chance of packet loss. When we talk about data link layer, we call it virtual circuits. And as I mentioned before, circuits is this idea where you have direct connection between sender and receiver. So that means you have a connection-oriented connection. And it will help you transmitting data from A to B because you have this global packet which goes through the line from sender to receiver. So all the following packets will follow the steps of this global packet, which means there's a reservation for each of these packets because as the global packet passes through, it will reserve all the packets coming afterwards. And you could say, therefore, it's also arriving at the same order. So 1, 2, 3 is coming, packet 1, 2, 3, 4 will end up in 1, 2, 3, 4 manner. Which also means there's less overload on the headers because the headers don't need to contain all the information because it will just follow the footsteps of the global packet. And in the end, it will also reduce the packet loss probability because now it's in the same order, the reservation is there. So the probability for packet loss is very low. The idea of this circuit network is basically, when we talk about it, the OCI model, is the physical layer where you have this circuit switching that contains this flow that's going through. There's no headers needed because you have direct connection. It's the same order. The problem with these things is that the efficiency is not so high because imagine this, if you have packet 1, 2, 3, 4 and 1 needs to get forward, then 2 needs to get forward, then 3 needs to get forward, etc. It will take plenty of time for all the packets to get through. Where you can say for the packet idea, you can send 3, 4, 1, 2, all of them at the same time, and it will end in the same time. But just it could just end up in another order than it is sent. That's the only problem with the circuit network, you could say. Other than that, the delay is also less because you have this same order principle and reservation from the global packet, which means there's not so much things going delay.